Alright, today we are looking at the second derivative and some of the things that we can find with it, including the second derivative test. These are some of the things we'll be looking at. Points of inflection are a big part of it. They are essentially the equivalent of critical points from the first derivative test. Concavity, which is equivalent to the increasing or decreasing regions from the first derivative. This is what we'll do is concavity in the second derivative. And we can use the second derivative test to find mins and maxes just like we did with the first derivative. So, first of all, concavity, what that means is that we look at concave up versus concave down. Concave up just means the derivative is increasing. Concave down means the derivative is decreasing. If the derivative is increasing, that means the derivative of the derivative, the second derivative, must be bigger than 0. Similarly, if the derivative is decreasing, then its derivative, f double prime, must be less than 0. And what we want to look at here, concave up simply means it kind of looks like a smiley face. It looks like it's kind of curving upwards. Same thing, concave down would be like a frowny face, curving downwards. That's just all concavity means. Points of inflection are just places where that concavity changes. And like we did before with critical points, that happens when our derivative function, in this case, points of inflection is the second derivative. It's when the second derivative equals 0 or when that second derivative is undefined. So to see how we use concavity, let's say I want to know where are the regions it's concave up, concave down. To do that, I need to take the second derivative. But before I can take a second, I must take a first. So 4x cubed minus 12x squared is the first derivative. Now, I need to take a second derivative here, which would be 12x squared minus 24x. I want to set this equal to 0 to find my inflection point. So 0 equals 12x squared minus 24x. I can factor that. I can say 0 equals 12x times the quantity would be x minus 2. So it means that at x equals 0 and x equals 2 are where I have points of inflection. Those are my x values. So first, points of inflection will happen when x equals 0 and when x equals 2. But remember, they're points, so we need to have y values. Y values, you go back to your original function, and we plug in and get 0 here, and I would plug in and I would get a negative 16 for this one, for that point. So those are two different points of inflection on your graph. So now we're going to look for where is it concave up and where is it concave down. We're looking for intervals where this is happening. Well, to do this is going to look similar to what we did with the first derivative. We're going to draw a number line. We're going to put our points of inflection right on here, so 0 and 2. And we're going to say, well, what is my second derivative in these regions? I know it's 0 at 0 and 2. What is it in the other regions? If I pick some number less than 0, I would have a negative times a negative, which would be a positive value, which means this should be a concave up region. So from negative infinity to 0 is concave up. If I plug in a number between 0 and 2, say 1, I would have a positive times a negative, which means this is a negative value. Concave down on the interval 0 to 2. And the last one, plug in a number like 3, something bigger than 2, I'd have positive times positive gives me positive. So that's another concave up region from 2 all the way to infinity. So that's how you do your concavity region. Now you can go another step forward with this into what we call the second derivative test. And that just says that if we're looking at, if we already know we have a critical number, so we found that from the first derivative, we test it using the second derivative. So if the second derivative is positive, that means it's concave, concave up. That means I have something like this. The only possibility is I would have a minimum at that point. Same thing here. If it's negative, that means concave down. That means we can have only a maximum at that point. So to show you how that works, what we're going to do here is use the second derivative test. First thing is we need to find the critical numbers. Well, by doing that, we do that by finding the derivative, 3x squared minus 12. I'll factor it, set it equal to 0. So I can pull out a 3. This would be x squared minus 4, which is 3x minus 2, x plus 2. So my critical numbers will occur where x equals 2 and negative 2. To see if it's a max or min, I need to take a second derivative. So I'm going to take a derivative of my derivative. That derivative will be 6x. To test them, we want to test at these 2 points. We want to plug in f double prime of 2, f double prime of negative 2. When I plug in positive 2, I get a 12. When I plug in negative 2, I get negative 12. With that positive 12 here, that means that this is concave up because it is positive. And when it's concave up, that means it's looking something like this. That means we must have a minimum at x equals 2. Same thing here. If I have concave down because it's negative, that means I have to have a maximum at this point, x equals negative 2. With one more example, I would recommend you pausing the video real quickly and see if you can do this, and then come back to check your answer. Alright, let's see how you did. F prime of x will be 3x squared minus 18x plus 24. Set it equal to 0 and factor. Pull out a 3. I'll have x squared minus 6x plus 8. That means when I factor that, I should have x minus 4 and x minus 2. That means my values for x, my critical numbers will come at x equals 4 and x equals 2. So now I plug in, I'm going to plug these into my second derivative, so I need to take the second derivative first. So I'll take it from here, and I will get 6x minus 18 as my second derivative. So I will plug in f double prime of 2, f double prime of 4. When I plug in f double prime of 2, I will get 12 minus 18 is negative 6. That means this is going to be concave down at this point, which means we will have a maximum value at this point. And when I plug in at 4, 24 minus 8 is a positive 6, so this will be concave up at this point, which means it will be a minimum value at x equals 4. And that's how you use the second derivative test to find maximums, minimums, and using it to find concavity.